Suppose now that I'm giving you the straight wire, but now it is vertical. And the circular is tangential, but can you see the difference now?
Yeah.
It is perpendicular to the level of the screen. The dashed line represents everything behind the screen.
Yeah.
And you have I2 upwards and I1 counterclockwise. And I'm asking you again, I'm giving you, the radius again, and I'm asking you to find the same thing. Determine the B net at the center of the loop. I'm giving you the same numbers. Let's forget the numbers. The numbers are the same. But what is the difference now? Can you tell me?
The direction of the field.
Yes. And now you can try to draw it, but in 3 dimensions. Sometimes it is really complicated, and you must be kind of talented in terms, of drawing to understand how to draw a 3-dimension sketch. How should we try it here? What do you think? Start with a simple I1. Let's start from B1. How is B1 directed?
Directly upwards from the center.
Great. Perfect. This is B1. Okay. And what about B2?
It would be into the page.
Perfect. And I can write it like this, right?
Yeah.
But now, how can I determine the resultant vector? How should I draw it?
It would be, would you be able to make a triangle for it?
Yes. So instead of writing it in this way, look, I'm erasing it. Of course it was correct. I can do it in this way, like a 3D. Let me read from here to show you what I mean. So in order to draw the net vector, this is supposed to be B2. I draw it in the equivalent way instead of into the page.
Yeah.
Now I can draw the rule of parallelogram, and I can show that this one is the net field, right?
Yeah.
Are you sure you get it?
Yeah.
So in this case, this is kind of complicated, I agree, but you have to know it. In this case, what is the difference? B net should be given by the Pythagorean theorem. So the same magnitudes like previously, this one, 4 times 10 to negative 7, and 8 times 10 to negative 7 remain the same. But you don't just add or subtract now, because two vectors are not on the same line, are not collinear to be precise. So you just do the Pythagorean and you are finished. Any questions?
No.
Okay, one more to finish it.
Okay.
Suppose I'm giving you another example. 2 parallel straight wires. I1 going up and I2 going upwards too. And this is the separation D. And I'm giving you that I1 is 1 amp and I2 is 3 amps. And the distance between them is 60 centimeters. Okay. I want you to determine where the net field is 0. Have you ever worked on something like this?
No.
Okay. This is really complicated, but this is the top level and you are okay after that. If you know this one, you know, the simplest, just drawing something out of the page, into the page, collinear vectors, you subtract and you are ready. The second one, 3D dimensions, which means perpendicular to the level of the screen, and you need the Pythagorean. And finally, sometimes it says two wires, and we want to determine a point or more than one point, any, that the net field should be 0. About it and tell me if you have any ideas.
Hmm.
In order to have net field 0, you must try to see if anywhere you can see these two vectors being
Yeah.
B1 must cancel B2 somewhere in the space around the wires, right?
Yeah.
Okay, let me help you. Do you agree that the level of the plane of my screen is divided into 3 parts? I have 3 regions. Region A, region B, and region C. A is at the left of I1, B is between them, and C is at the right of I2. Okay, let me show you this. Can you go and work region A first and tell me the directions of B1 and B2 out there?
It would be into the page.
Which one?
For A. For
I1?
B1.
No, it is out of the page.
Oh.
I1 is going upwards. Put the
Oh,
thumb.
yes. Yeah.
The fingers are going into the page here. Look. At the right. And of course, out there. Do you agree?
Yeah.
But for B1, at region A, it comes out of the page. The same for B2. And I think that you are going to agree with this. Huh?
Yeah.
Okay, so the first thing is this. You have to understand that you have 3 different regions of the whole plane, and you go and work on any region separately, and you determine the directions of the fields. Any questions? And now, is it obvious that 2 vectors coming out of the page or both coming into the page cannot give something like this?
Yeah.
So, if any possible answer can be found, it would be somewhere over here, right? So let's say that at the position P, at a distance x, in region B, we have to find out if there is any point like this, right?
Yeah.
So at this position, B net at P should be 0, which means that the magnitudes of B1 and B2 must be equal. So you have nu O I1 over 2 pi x equals nu O I2 over 2 pi d minus x. This is the distance from here, d minus x, isn't it?
Yeah.
Okay, nu O is cancelled, right? 2 pi is cancelled. Let's go. 1 over x, I'm substituting the numbers now, equals 3 over d minus x.
Yeah.
3x equals d minus x. So 4x equals d, and x equals d over 4, which means 15 centimeters. So this is the answer. There is not just a single point, but all the points. Can you see the dashed line I'm drawing?
Yeah.
All the points of this dashed line having the same distance x of 15 centimeters from the left wire have a 0 net field on them.